question 9, the last question on the core 2 paper, uses a variety of different techniques, particularly using logarithms. So the first one, we've got a curve, we're given its equation, we're told there's this point on the curve and we want to find out what k is. Well, if the point's on the curve, it must satisfy the equation. So in this case, instead of x we've got k, and we know that y is 6. So we're just going to substitute that in. So 6 equals 3 times 12 to the k, because the point is on the curve, so it must fit the equation. Now make sure here we've got two different base numbers, 3 and 12, so they cannot be multiplied. So our first step to solving this is to divide by 3, and you get 2 equals 12 to the power of k. Now you can solve this directly with the calculators, because we've got k up as a power and the base is 12. Now that means to solve this directly you're going to do log to base 12. So if you do log to base 12, you get log to base 12 of 2, log to base 12, 12 is the inverse function, so we just end up with k. And so k is log to base 12, 2. We just go into our calculators, log to base 12, 2 is 0.279. These are equivalent statements. It asks it to fit 3 significant figures. There is an alternative if you want to do logs of both sides. So going from this stage, you have to have the same start. What you can do is just use any log, like log to base 10, and you can just take logs of both sides. We then use the log laws to drop the k in front, and so k is log on its own is by default log to base 10, so log to base 10 of 2. You could use ln if you're doing this as a VTake, and you know what that means. So k is log 2 divided by log 12, which gives you the same answer. And divide it to decimal. Right, so then part B is the trapezium rule one. Now, I would say there's pretty much always a trapezium rule question on the core 2 paper, so you need to know and use the trapezium rule. So on the trapezium rule, with 4 ordinates, which is 3 strips, to find an approximate value for this integral. Remember, it's only going to be approximate because it's using trapeziums to estimate a curve. Right, trapezium rule, 4 ordinates tells us how many x values we're going to have. So we're going to do a table from our calculator where we want to go from 0 to 1.5 using 4 x values. So it's going to be 0. If we split this up, we're going to have 0.5, 1, 1.5. 0.5, 1. 1.5. The trapezium rule is in your formula book under numerical integration. It's written out here, but a lot of people like to just remember it. First step is we do need our table of values. Now the easiest way, you can either substitute yourself or you can use your calculator to get this. This is the function that I've labelled y in my table. It's the thing we're trying to integrate. So if you're going to do this with a table, you go mode table, f of x is our function, remember don't combine those, so 3 times 12 to the power of x, there's no simplification, they won't give you something that can be simplified, they would have done that for you. So we start at 0, go up to 1.5, our step size is 0.5, and there's our table of values, and you can just copy these out. Make sure you use all the places you use, so it tends to show 5 significant figures, so make sure if you're doing the table of values you do this. Remember, it truncates, it doesn't round properly, so it's worth checking that the value it shows in the table is the correct one. So that one's 36 and that one is 124.71. You can do this just by substituting in yourself. and then you can have some more accurate surds in the table. Once you've done that, we're going to use the trapezium rule. So the trapezium rule says I'm going to use I integral is approximately a half times h. Now h is your step size, so that's 0.5, it's a half, times y0 plus yn. Now that means the first y plus the last y. So this one and this one. So 3 plus 124.71 plus 2, and then there's a whole load of y's there. That's 2 times all the ones in the middle that you haven't used yet. So that's 2 times 10.392 plus 36. Okay. And then all we need to do is go back to the first mode in our calculator and type all of this in. So I've got a half times a half times 3 plus 124.71 plus 2 times, and this one the brackets are important, 10.2. Make sure we close all the brackets and press equals. So I've got, that's approximately 55.1235, and then we're going to check in the question 2 significant figures. So that's 55 to 2 significant figures. Remember, you can check that you are in the right kind of area with your answer using the integration button. We just type in the original question using alpha for x, put our limits in, and the calculator tells us that the answer is 48.97 and some more numbers. 48, fairly close to 55, so I've probably got that right. I would worry if the calculator said the answer was 200 and I had 55.